Assume the probability is 1/2 that a child born at any time is a boy and births are independent. What is the probability of the event that if a family has 5 children, no twins, none of them are boys? What's the probability of that? Okay, so again in this section we're looking at multi-stage experiments. So this is 5 separate actions, and every time you do an action, you do action, well you do, let me change that up, you do the probability of the first action times probability of the second action times probability of the third action times ... You just multiply those probabilities together. That's what we're learning about and. You can make a big tree, but we don't need the whole tree this time. We can just say, what's the probability that the first, what are they saying? None of them are boys. So the probability that the first one is a girl, to have no boys, you got to have 5 girls in a row, times the probability that the second one is a girl, times the probability that the third one is a girl, times the fourth being a girl, times the fifth being a girl. That's what we got to figure out. What's the probability that you're going to have a girl? Well, it's 1/2. Times 1/2 the second one's a girl, times 1/2 the third one's a girl, 1/2 the fourth one, and 1/2 is the fifth one. That's the probability that all 5 are girls. 1/2 for the first, 1/2 for the second, etc. So you multiply those together, that's 1/32. It has multiplied all the numerators and all the denominators together. That's the probability of having 5 girls in a row, meaning no boys. 1/32. So the moral of the story is that when actions happen one after the other, you multiply their probabilities together. You want to have a girl and another girl and another girl and another girl. And always means multiply, or will mean add. We'll get to some of those examples, but this is and here. We just multiply those together.